In this video, we will learn to write the equation of a line in point-slope form, then rewrite it in slope-intercept form. The point-slope equation. The equation y minus y1 equals m times x minus x1 is called the point-slope equation for the line with slope m that contains a point x1, y1. Here's an example. Write a point-slope equation for the line with slope -3. Now slope is m, so m will be -3. That contains a point 4, 9. So the value of x1 is 4, and the value of y1 is 9. In the point-slope equation, the m will be replaced with the slope, and the x1 and y1 will be replaced with the point that is on the line. The x and y will remain variables. In this example, y minus y1, which is 9, equals to m, which is -3, times x minus x1, which is 4, will represent the point-slope equation of a line. Here's another example. Write the slope-intercept equation for the line with slope equal to 3 and containing the point 4, 3. Even though we want the equation in slope-intercept form, we will start by writing the equation in point-slope form. In point-slope form, which is y minus y1 equals to m times x minus x1, we need the slope. In our case, the slope m is equal to 3. And we also need a point on the line x1, y1, which is 4, 3. So x1 is 4 and y1 is 3. So in point slope form, our equation is y minus y1, which is 3, equals to our slope, which is also 3, times x minus x1, which is 4. But our directions are to write the equation in slope-intercept form. In slope-intercept form, recall that the y needs to be isolated, since slope-intercept form is y equals to mx plus b. So in our equation in point-slope form, y minus 3 equals to 3 times x minus 4, we will need to solve for y. To solve for y, let's first distribute the 3. We will have y minus 3 equals to 3x minus 12. Since y is being subtracted by 3, we will add 3 to each side, which will give us y equals to 3x minus 9. This is the equation of our line in slope-intercept form. Here's another example. Write the slope-intercept equation for the line with slope equal to -3/5 and containing the point 3, 2. First, let's write the equation in point-slope form. In point-slope form, our slope m is -3/5 and x1, y1 are 3 and 2. So the point-slope equation will be y minus y1, which is 2, equals to our slope -3/5 times x minus x1, which is 3. But we need to write this in slope-intercept form. So in slope-intercept form, we will take our point-slope equation, which is y minus 2 equals to -3/5 times x minus 3, and solve for y. So first, let's distribute the -3 over 5. We will get y minus 2 equals to -3/5 times x minus 3/5 times -3. Now, anytime we multiply a fraction and an integer, it's easiest to rewrite the integer as a fraction by writing it over 1. So we have -3 over 5 times -3 over 1. Remember that when we multiply fractions, we don't need a common denominator. We simply multiply the numerators. You have a negative times a negative, that's a positive. 3 times 3 is 9. And then multiply the denominators. 5 times 1 is 5. So once again, in multiplication, we do not need a common denominator. Simply multiply the numerators and multiply the denominators. But to isolate the y, we will now need to add 2 to each side. So we will add 2 to the left side and add 2 to the right side. Anytime we multiply, divide, add, or subtract a fraction and an integer, rewrite the integer as a fraction by writing it over 1. Once again, anytime we add, subtract, multiply, or divide a fraction and an integer, rewrite the integer as a fraction by writing it over 1. So now we have y equals to -3 over 5x plus 9 over 5. For adding and subtracting fractions, we do need a common denominator. Because the denominator of the fraction 9/5 is 5, we will need to rewrite 2 over 1 using a denominator of 5 as well. For that, we will need to multiply the denominator by 5, which means the numerator also gets multiplied by 5. So 2 times 5 is 10, 1 times 5 is 5, and 2 over 1 can be rewritten as 10 over 5 using a denominator of 5. Once we have a common denominator, we will add the numerators. So in slope-intercept form, our equation is y equals to negative 3 over 5x plus 9 plus 10 is 19 over 5. Next, let's write the slope-intercept equation of the line containing the points negative 7, 1 and negative 5, 11. So when we write the equation in slope-intercept form, we need to start in point-slope form, which is y minus y1 times x minus x times x1. For this, we need to know the slope. Recall that we can find the slope using the formula y2 minus y1 over x2 minus x1. Using these 2 points, y2 minus y1 will be 11 minus 1. x2 minus x1 will be negative 5 minus negative 7. 11 minus 1 is 10. Negative 5 minus negative 7 is negative 5 plus 7, which is 2. And 10 divided by 2 is 5. So the slope m is 5. We are given 2 different points, the point negative 7, 1 and the point negative 5, 11. We could pick either point and we will give the same answer for slope-intercept form. I will pick the first point, so my x1 will have a value of negative 7, and my y1 will have a value of 1. If I pick the second point, again, the result would not change. In point-slope form, since I picked my y1 to be 1, I have y minus 1 equals to our slope, which is 5, times x minus x1, which is negative 7. Let's solve for y. We have y minus 1 equals to 5 times negative negative 7 will become positive 7. This becomes x plus 7. Then we will distribute the 5. This will give us y minus 1 equals to 5x plus 35. And then finally, we will need to add 1 to each side, giving us y equals to 5x plus 36. We can always check this to see whether we did it correctly. In order to check this, we will take either point and replace the y with the y value, the x with the x value. Since we use the point negative 7, 1 in our point slope form, let's test the equation using the point negative 5, 11. For that, I will replace the y value with 11 and replace the x value with negative 5. 5 times negative 5 is negative 25. Or sorry, this should be 36. And negative 25 plus 36 will be 11. Since 11 equals to 11 is a true statement, I know that this equation is correct. Let's do one more problem. A person's target heart rate is a number of beats per minute that bring the most aerobic benefit to his or her heart. The target heart rate for a 20-year-old is 150 beats per minute, and for a 60-year-old, 120 beats per minute. Let X represent age and Y represent the heartbeat of a person. Write each set of data as an ordered pair. Since X represents age, for a 20-year-old, the value of X will be 20, and Y represent the heartbeat. For a 20-year-old, the heartbeat will be 150 beats per minute. So the corresponding ordered pair will be 20, 150. For a 60-year-old, the X value will be 60 since X represents age, and the heartbeat per minute will be 120. So the corresponding ordered pair will be 60, 120. Next, write the equation that models a set of data in point-slope form. So for point-slope form, we first need to know what the slope is. The slope is y2 minus y1, which is 120 minus 150, divided by x2 minus x1, which is 60 minus 20. 120 minus 150, that's negative 30. 60 minus 20 is 40. If you reduce negative 30 over 40, this will give you negative 3/4, which is the slope. Now we can pick either the first point or the second point as our x1, y1. Let me pick the first point again. So my x1 is 20, my y1 is 150. So in point slope form, I have y minus y1, which is 150, equals to my slope, which is negative 3/4, times x minus x1, which is 20. Part C, solve for y and rewrite the equation in slope-intercept form. So once again, my equation in point slope form was y minus 150 equals to negative 3/4 times x minus 20. To rewrite the equation in slope-intercept form, we must distribute the negative 3/4. This will give us y minus 150 equals to negative 3/4 x minus 3/4 times negative 20. Now recall that when we multiply a fraction and an integer, we write the integer as a fraction by writing it over 1. 4 goes into 20 5 times. Negative 3 times negative 5 is 15. So we will have y minus 150 equals to negative 3 over 4x plus negative 3 times negative 5, which is positive 15. Finally, let's add 150 to each side. Our equation so far is y minus 150 equals to negative 3 over 4x plus 15. If we add 150 to each side, then our equation becomes y equals to negative 3 over 4x plus 165. This is our equation in slope-intercept form. Finally, using the equation in part C, calculate the target heart rate for a 48-year-old. Now we have to think about 48, does that represent the x or the y? X represents the age and y represents the heartbeat. Since 48 refers to the age, the value of x will be 48. In our slope-intercept form, we will have y equals to negative 3 over 4x, which is 48, plus 165. 4 goes into 48 12 times. Negative 3 times 12 is negative 36, plus 165. Now recall that y represents the heartbeat. So the heartbeat of a 48-year-old should be negative 36 plus 165, which is 129. So the target heart rate of a 48-year-old is 129.